Hello and welcome back to another episode of Gifting Good Oxide. Welcome back, Sydney. Ooh.
Hi, Sebastian. Good to be back.
Yeah, this was a longer break, 1 week without a review. But since then, a lot has happened, and I didn't look at it at all. So feel free to give me the tour, the summary.
Cool. Yeah, so basically I started looking at the actual Git PathSpec implementation and just, scanned the file to try to implement their errors just to see where they actually throw or die and see what kind of errors they actually have and try to pull them over. And there were actually quite a few things that that I was still missing basically. And so I added a bunch of test cases and adjusted the code accordingly to make sure everything still works. And on the way, a bunch of refactorings as well. Some things turned out to be a little bit nicer. Other things, not quite there yet, I think.
Okay, sounds great. So you're already in the kind of last phase of any development. You don't only test against Git as baseline, but you also scavenge through their code so that you can find the nitty and the gritty. And you found some, even though I did not, I don't have. And welcome back after the break. So that was a connection reset of some sort. And we are back with me saying I have no idea what errors here are new. But for the review, I thought we can actually go through the session notes of last time and see what was addressed and what wasn't.
So I basically split those up into kind of two categories. And one was stuff that was related to Git attributes or like that were things that I would have had to adjust in the Git attributes crate, which I didn't touch yet. But the rest is actually addressed and done. So so that would be the first one here, and the second last.
So you say the first one, could attribute name use the same idea as used for full name? All right. So that is still there because it touches the Git ref crate, right?
The Git attributes crate. I think that would be changed in there.
Yes. Okay. Git attributes crate. That's still there, and the last one.
Second to last.
Second to last. Could Git attributes parsing error be more distinct? Yeah, because we did some dance around using that. Okay, but the other ones are addressed.
Exactly. There's some tests for white space now in the path sections and in the short signatures, and they should all work. I think it's even labeled white space.
White space and PathSpec. And there's different ones.
Yeah, anything that basically is valid, and it doesn't trim white space in the paths whatsoever. So at the moment it's just keeping it. I'm not sure what the desired behavior is there, but at least it's defined here.
Yeah, good. I think you can test that in Git what the defined behavior is by running it through Git potentially. Does that run through Git here?
It does, but it doesn't check any matches or anything. It just checks if the Git command fails or succeeds in general.
Interesting. Here it doesn't like. Oh no, wait! I'm checking the wrong one. I check what it inputs here.
Yeah, exactly.
Is that it gets? Oh yeah, good. But it doesn't check if it trims. That's true.
Yeah, I can't check the output of the PathSpec parsing. I can just see the matches that come out and kind of guess. But yeah, it doesn't trim white space from the front, I'm pretty sure. Like if you try that, it doesn't work. From the back, actually, I don't know.
This means that this could work. Like if you had a repository with the files that you're testing against, even with white space, then you could validate that ls files now list that file, so Git does not trim by its white space. And I would expect it not to trim, by the way, because Git never does that. The shell trims white space. I think that's the general assumption of all Git commands. And you know that shells do that, and this is what you use to your advantage. But otherwise, if you manage to pass a white space by properly escaping that and whatnot, Git will not just trim it away from you, because that would also mean they have to now make it possible to escape that you know, you want to be able to have white space at the end. And then they have to implement escaping, which then has to go through the shell escape and git escape. And you see this just complicates matters. Huh? So I think this is why we kind of know git will not trim. And we can, you know, I'm fine with just manually validating this once. And then you don't have to test it here. That's okay. Because I think git is consistent in that regard. But we talk more about the way this is done here, because I've got a nicer way now, finally. I've talked about this before, and I said, yeah, I know it's fine, it's fast enough, but then Windows, and it's kind of still fine, but I have a nice way of working around this, I think, which is, you know, kind of how I have always done it, but a bit with a twist. I have something to show there. Okay, then white space, done. Test to assure valid portions aren't repeatable. Motivate a break. Right.
I wasn't so sure what that meant anymore, but I assumed that it was basically like testing for repetitions in the signatures.
Yes. Yes.
And we have a test for that as well.
How's it
in the succeed.
Repeated matcher keywords? Because I thought, yeah, with attributes. So I think the example that we had was, if you use attributes and they're not actually empty, then what happens?
Yes, so there's also a test for that. So just really quickly to understand, if you just have the letters ATTR, it's a valid keyword, but it doesn't do anything. It's like a no-op. But as soon as you have a colon behind that, it expects some values. And if there are no values, this is an error, so missing attributes. And if you have two of these, then it's you can't have multiple attribute specifications error. And there's also a test for that somewhere in there.
There we go. Because I think this is the one that I was looking at last time. Should I be concerned that I remembered this kind of stuff after 2 weeks? That's strange, really. It's this freak brain. Because I do not usually have a good memory for stuff. But yeah, this, I remember. It's also because the only special one, it kind of makes sense. Like, if you know how this works, you have an enum, and we have attribute parsing, and we have bin flags. And with the enum would also be interesting, like exclude and something else, ignore, I don't know. Two were mutually exclusive, right?
Yeah, it's literal and glob, I think.
Literal. And then the question is, what happens? Like, is there an error if you have both? Probably, huh?
There is this one, yeah. This is the error case.
And in theory, that should just trigger, huh? So if I go with this, it should probably not change anything. And it doesn't. Okay, good. And the other duplications we already had. Yeah, okay, cool. And then the last one was the attribute one, and we already know this works. It's an error. And for Git, it's also an error, right? We don't make anything up there that Git does.
Git, so the error cases or the fail cases are also run through Git.
Right.
It's just checking if it fails in this case.
Cool. Perfect. Yeah, see, that's all we have to know. Then we are comfortable. And this is done. Because the rest, it just stops parsing at the end anyway, huh? Like it consumes to the end.
Not in the error case, like
yeah.
Or what do you mean?
Like if there's a path in the end. So if I do this,
yes,
it will not
part of the path.
Yeah. Okay. Good.
because there are some conditions before basically that always stop the keyword parsing basically.
Yeah, and that should be that this is then consuming. The path is just taken for granted to the end and no special handling, more or less. I don't know if there is special handling. Maybe I saw we've been working on escaping as well.
Yes, that's yeah, exactly. That's one of the other points that I still found while checking the Git implementation. But I think the rest is pretty much done anyway.
Clippy is happy.
Yeah, I think Clippy is happy. Yeah.
And this is a real fast machine. Still takes time. Getting there. A million.
This is checking it for the entirety of Git oxide. Is that only for that crate?
Yeah, I only have one, but that also explains why it's so long. I probably have a more fine-grained solution for that. And fix ignore test. There's only one ignored that is prefixed, but it's a new one, so I think we can.
It's a new one, yeah.
Repetition tests. All right.
Exactly. And yeah, like I said, there were a couple of things that I found in the actual Git implementation, some that I didn't really understand. There was, for example, prefix. There's no real documentation about this. I just found it in the code. And yeah, these escaped values inside attribute values, which is something that, I don't know, maybe the Git attributes crate handles wrong at the moment. I'm not entirely sure there as well.
Right, attribute parsing. I thought there wasn't any escaping because I also looked at this, but maybe I missed that. And yeah, Git attributes is its own beast, so maybe also I've overlooked escaping because I was so focused on all the other stuff which seemed more important. But yeah, so you think escaping is happening and it's in Git attributes, or is it also in PathSpecs?
There's a test case for this, actually, I think a few even. And if you check for something like, what's the test called? Something with escaped attributes with escaped values. Oh, sorry, in the PathSpec test file. Up here.
Here?
I mean, this is one of them, but yeah, okay, no, this is the one exactly. So you have an attribute with like a key value pair basically, and in there, escaping is allowed for certain characters. And because comma is my split basically for attributes, for keywords, I had to basically change my splitting logic. But if you look, it's basically not escaping the output. So in the expected part, it still has the escape character in there. And I'm not sure if that should be the case or if it should be unescaped by the attribute parser.
Yeah, this should be something that's testable, huh? Also in Git attributes, which should run it against Git as well. I would expect Git attributes to some extent have a Git baseline, even though I think it's messy. Like this is the kind of baseline I don't like so much. It's the thing you come up with that kind of does something, but you never want to touch it again. So yeah, something to look into. It's mainly to see what Git does there, huh? So what we would want to do is pass some escape characters in and see what is actually applied. Is there
exactly.
Like there is the Git check adder. Have you used that before?
No.
So that pulls attributes from the Git attributes files, and you can just show what's there. So if I would look up target, so would target is ignored. Oh no, wait, that's ignore. Yeah, right. Git attribute. So now I would have to find one of these, get generated archives. Git repository, test fixtures, generated archives, and then one of these. And now it lists you all the attributes that are set. And now in theory, here we can do escaping, right? So we can set dash minus foo, and it should be minus foo and not subtract foo. And that's not a valid attribute name, okay. So I don't know if it's like for, I think I looked at the parsing code for Git attributes, and this is how it parses it. So there's no escaping as far as I know. Like I would have seen it, I think. So if there is escaping, maybe it's specific to PathSpec.
It is because, like I said, the separator for the keywords is a comma, but a comma is an allowed character in an attribute value. So yeah, that's true. The escaping only happens in the PathSpec because you have to do it, otherwise the splitting doesn't work.
Okay.
So that means
so we can
have to unescape the value before passing it to the attribute class parser.
Foo bar is also not a valid attribute name.
You have to give it a something equals foo bar.
Yeah, but the thing is, if comma is an attribute name that you want to be able to pass, then we can simulate that here, right? And it's not valid.
It's always in this something equals a value. That's what I mean with attribute value. It's in this form. Yeah, and then the value can have a comma. Yeah.
Okay, got it. Okay, this is why we have to be able to pass it. And probably here, now we're able to do this.
Yeah, that should be allowed.
And that must work, and maybe that doesn't work.
And there are only certain characters that are allowed in there, and that is also specified somewhere in the PathSpec file.
Yeah. So, yeah, this means you have to escape that.
Okay.
And you could escape it after it was parsed, like, oh no, wait, maybe not. I don't know. Like, if Git attribute says that the attribute name is not right, but it's never right, I think, because any character you could escape in PathSpec is never going to lead to a valid attribute name, because I think the only thing that's valid is dash, underscore, and A to Z, and basically alphabetic characters and underscore and dash. It's really not much. So maybe dash is special, I don't know. So there is a function, get attributes somewhere that are valid.
Exactly, that's what I found, yeah.
And that's the attribute name as well. So I think among these characters, if they're special for you, then you have to escape them, and this is why. But nothing else, really.
Yeah.
It's really these.
So, okay, exactly. And then for the names, it should be fine. It's really only for the values that can also have a comma in there. That's why that's the only special character for me then.
True. Okay, so first session note for today, great.
Perfect.
Cool. Yeah, I think now we are through kind of the obvious things without having had a look at anything else yet. And, you know, I think in the interest of time, we are like 20 minutes in the recording. I'd love to finally conclude, hopefully, my issues that I had with this. Issues is such a strong word sometimes. Not, you know, it's just, it's not done like that elsewhere, but there it was a bit different too. Why is that? Is there better ways? And I had the same I was in the same situation like you are here, I think. And I kind of solved it the only way I knew how to solve it, but with the twist, and I think the twist is what's the important thing here. So, or the fun thing. Let's go into ref parse delegate. And have a look. Okay. Make ref parse repo. So this is just me creating a bunch of repositories in the same directory that kind of create particular states that are then later tested. And what's interesting is this here, the baseline function. And in this case, it's ref parse. So I want to know what Git does when I call ref parse with these specs. And it can succeed or can fail. And I'm particularly interested in success cases, in that I want to know which object it finds specifically. And if there's an error, it's okay to just note that there's an error. I don't care about the actual error message. Mm-hmm. And this is how it's implemented. So get the spec, and then we echo the spec, and we echo the result of the spec, ignoring errors. And if it's successful, then I always get some sort of object output, some object hash. And if it's not successful, I just echo the error value. And this then looks like this. So you see it's always first line, second line, first line, second line. And I just try to parse this first line, the second line as a U8. Because that should be an exit code. And it's always kind of 1, right? But I even overcomplicate things. You can just check if it's 1, because it's always 1. I parse it. So if that parsing fails, then I try to create an object ID from a hash. And that's all this can do right now, the parser. It's always the same. And it's trivial to write that parser as well. And so all I have to do is just make sure that I put these baselines in there explicitly, because later in Rust, I'm going to use that spec too, and I'm going to compare against the baseline. So why is it that this is faster? Well, for one, the baseline file is created once. So you spent the time only once. Right now, I use the archival mechanism of the test suite as well. So on Windows, this would just be extracted and placed there, and no git runs again, which should be fine in these cases, right? And remember, all this archival and extraction stuff on CI, on Linux, it will not ever use archives. It will always run the scripts. So we don't run into the problem that we always work with cached values, and nobody even sees that Git stopped working or something like that. So CI will always bark it here. And then here's the implementation. And here is the test. And this is the trick here. So my question was, how can I use the baseline quickly without parsing it each time I run a test against it? Because you still have to kind of parse these values. And previously, the baseline, I think there was just one test that parsed the baseline once and then ran a ton of tests against that. But now I have multiple tests that all want to use the baseline for particular specs. So now parse spec just uses the baseline and just expects the baseline to be a hash map given a spec, give me some object ID that I expect to be there, or in case of error, it should be none. And this is ultimately what the lookup looks like. And this baseline here, that's a lazy. So there's a once cell crate that has the lazy type in it. And it's a static magic kind of thingy that gets executed only once per program. It's thread safe and everything. And this is where you then parse your stuff. And in my case, I build a map and I just dump the map here. It's not even protected by mutex because it's read-only. And that makes it all right to use statically. And that's all. And from there, you can fiddle around with that then freely in your tests. And you also,
and the map is basically like the name of your test case of what you're testing. So that's how the lookup works. There's like a name and then the value associated with these. Yeah. And that's how you can test each test against a certain baseline.
Yes. So the spec is the key, the ref spec. And I parse this flat file into a hash map keyed by spec, and then I just assume, and I test for that there's never duplicate specs happening. Because then this would be troublesome. Different repos, same spec could be different results, have different results, whatever. So I have to make sure of that, but let's test it here as well. And that should be fine. And if there is a baseline missing, which happens to me all the time, I always forget that, it barks at you too and tells you which spec is missing. So it's really easy to use, except that you have to touch your file a couple of times here to get these baselines. And I like that.
Yeah, that's really nice. So you just have a specific file that creates the baseline, and that's then being cached with the test tools basically, and does all that magic, and then you can just load it in and test against a certain parsed map.
Yes. And it comes at a cost which clearly is you now have to put that into a file, everything you do. And you can't automate that either. It's just something you have to do by hand. And this comes at the benefit that you could potentially create a repo that really has the files that you test against. Like you can do more now. The baseline doesn't have to be true or false. The baseline could be what is it that Git finds. I would not go there, by the way. I would start with true and false. And be happy about that. For you, it's mostly duplication, I think. But also, it's doable. It's something to think about, because I still kind of, think that it's okay to run these tests. Like, you want to run them. Like, how long does it take now? Oh, PathSpecs. No tests were found. What's going on? Ah, yeah, right, because I'm in the wrong. So we are at 220 milliseconds. And let's quickly run this on Windows. Yes, and on Windows, it runs for 10 times as long, more or less. Nearly. 8 times maybe. So significantly longer. I mean, it's not really that bad yet. It's just something, if you feel it, I think I can write that down. And we are back. So the time it takes on Windows is not too bad, but we might wanna consider doing this, and then we can run it again.
Yeah.
Will probably run just mostly as fast as it runs on macOS or whatever. Okay. And yeah, that's the only thing I wanted to show off, really. As the last thing, now we can, if you want, use another couple of minutes, 10 maybe at most, to look at the actual implementation.
Yeah, we can go through the code. Something's changed, and might make sense to just go through really quick.
Yeah, if there's anything you want to highlight, you can, of course.
So I did remove the attributes bit flag because we have a vector that we can just check if it's empty or not, and it was a bit redundant to basically set both. I'm not sure if, I think it makes sense to get rid of it. I don't think it's necessary.
Yeah. Less is more. I like that.
Yeah. And yeah, exactly. It's just these. And yeah, like this function got a little bit shorter because I managed to refactor these into, yeah, better named functions, I guess, to see what they do.
Parse short keywords, and that only produces the signature. Then we have long keywords, and the rest, that's what I meant with consuming. The rest is really just the path. And that's cool. Yeah, looks nice, huh? Looks really tight. Yeah, I do have a suggestion. I do have one. So it's this pattern here. It's this assign everything, and then later
You said it.
drop it like this. You probably know what I'm going to say. You know it?
No.
Because, okay, cool. Because now you have to go through P all the time. And it feels a bit redundant, and you already name it P, and if you could name it half a character, you would probably do that too. Because you don't really want P, I have the feeling. You don't want P.
Yeah.
And I don't think you need it.
So you just split it up into their individual.
Yeah. Like you split it up and later you recombine here. And that should work. If I didn't miss anything, no, because you really assign only to fields here of P. And if you do that,
Yeah.
I think you don't really want that.
Yeah, I mean, I know what you mean, definitely, and that's how it started out. It might be a bit shorter if you get rid of the pattern under like on the outside of it, but that way it's also really clear, I guess, like what's happening. I don't know. Yeah, it's not really sure.
So you had that before, you mean, and you went to this
Yes.
one explicitly.
I mean, I didn't have it in this form. It started out a bit earlier, which then made it look a lot cleaner from the previous version of that. But yeah, maybe I have to try it out again, see what that looks like.
Okay, now you sparked my interest. So you see this, like, I'm just going through that stupidly now. And we will probably have a second round.
Yeah, okay.
And this isn't needed anymore. Signature starts empty. Search mode starts with a particular one. And attributes start. So see here? So that's always something I look at. Like we initialize and then we assign. That's okay. But we don't really care about this original value at all. We just...
Yeah, absolutely. You do have to carry it down somehow.
Yeah. And that's okay, but it strikes my interest. Can this be any more idiomatic? And I'm really asking the question like this pattern, for instance. This happens only once. And then we assign, and then we are done with it. Also interesting. Like, you parse short keywords here, and the cursor does not get... the cursor is passed in, so it's changed mutably.
Mutating in the function, yeah.
Yeah.
I was curious what you're going to say about that.
Yeah, I'm sure you did it to be able to write that. Like, take the output value and...
going with it. Otherwise, there's a lot of math involved, basically, on how you have to shift, like slice the input, shift the cursor. So I thought maybe this is a lot easier to do.
Honestly, if you manage to do anything, and I had to highlight it, it's that you use the cursor very efficiently, and it looks pretty good and clean. So I wouldn't say anything. I wouldn't dare to raise my voice against that. And I think I'm curious about that pattern here. Right. Now I get it. So down here we create a pattern, but here we also create a pattern, and I think you do it because it's mostly what you want.
Because this was the long clippy signature thing, because it has to give back a lot of different things, and I thought maybe it's easier to just, because it's essentially doing a pattern just without the path section.
So here's this initialization again.
Yeah, same method as before.
Same values, same method. So maybe I changed my mind then, somewhat, because like once the answer is clear for this one here, should this be pattern, should this be something else, then I think we know what to do further up as well. Because my intuition here is it wants to have a default implementation, which is only really ever useful. Like, who wants a default pattern? It does nothing. It's really...
it's only internal, yeah.
It's only internal, so this is why I would want to avoid it, but also kind of I would want to avoid this duplication. I mean, duplication, it's more like, is it necessary? Here we go with the pattern again, even though we have to return a pattern, so that makes sense. But do we really have to return a pattern? Or is this more like...
We have to return 3 out of 4 parts of a pattern.
Yes. Let me look again.
In this case, at least.
So it always parses it, even though it could be... It could be an empty pattern. And that's the unusual case, I suppose. That's more something that we have to deal with. So nothing to worry about. Then we never have a path. We do have a signature. We do have search mode. We do have attributes. So we have everything. It's like the whole parse, like we have these shortcuts here. And then we have, doesn't this want to have a mud p? And here the same? I wonder.
That would make things easier, yeah. Then you create it once.
And because if you return it and then use parts of it, I don't like that. Oh, now there's a path that isn't worth anything because reasons. It's like, I think it should be a different type then. Or it's, if you do this, then I can live with the fact that it selectively assigns certain values. That's fine. Then you don't have, I mean, just maybe it looks ugly and terrible and you don't want that. So I don't think here it's necessary because that's just a signature, huh? So here it's cooler to just assign it like this. But here, not anymore. So I think this is more like what it wants to be. And since you then don't do so many assignments anymore, you can call it pattern or pet or whatever. You can make it a bit longer then and a bit more descriptive. Yeah. I think then you save all of this and something else you can do, by the way. And then you are in here, right? You're in here and that's the last thing. And I now hack it to death as it will not work anymore. But here you have a pattern P. And what you can then do is this beautiful thing. Just destructure it and say you want the signature and you want the search mode and you want attributes. And now you don't have to use your P prefix anymore at all. And you will do what you do. And it's kind of obvious that these 3 are important and nothing else. And that kind of solves all issues. And that's better, I think.
That's quite nice, yeah. Saves some space.
That's all what it is about. We don't want big files in version control because Git is so slow until Git Oxide arrives, you know. No. I mean, all of this can go away, huh? And then all of that goes away, more or less.
Yep.
And then we just need the pattern back here. And down here, we have the pattern. And the pattern path assignment, of course, you have back, input, cursor, something.
Cursor till the end, yeah, and bstring from wrapped around or into. Maybe that works. Well, no, probably not.
I think that also works. Whatever it is. And that, I think, is as good as I can make it from the glance I took so far. And then back to this one. I mean, it's mostly how it was before.
Yeah.
Needs research. What does prefix do, right? And that's the ignored test there. There was a... All right. Cool. Then as the last session note, I think I'll try to pass matp2 parse long for much less boilerplate. Destructure. All right. I think that's it. Everything else seems so tight already. Split non-escape char. Oh no, this is actually...
This is new, yeah.
This is interesting.
I'm not sure if this is as good as it can be, but I needed a way to, you know, split, but based on 2 characters basically. And I couldn't find a different way of, just looping through it basically, manually.
I know that with bstring there's a lot of added capabilities. But it doesn't have split, it only has find. But find, like byte set, then it's one or the other, or any of. And that can be turned into split relatively easily, I think, because find position. Yeah. You find...
So I tried, I went down this route and basically did a filter map and to find only the positions at which, you know, the special case occurs. But then I couldn't find a way to take that array of indices and turn it into a split.
Yeah, I mean, you can probably start, you know, you try to do it in a compressed form already, like functional and filter, map, fold, reduce, magic thingy.
All that stuff.
And that's cool, but it's also the hardest. And you can easily run into issues. So in order to validate that this generally works, I would probably just go with a handwritten imperative old school loop and then see if that works.
As you can see here.
And I mean, this is the one that really does it manually, but you know, this is also find. This is find byte set handwritten, so to say, specifically. Because find byte set will do that for you. It will find whatever, you know, it will find like 1 or 2 characters, right? So, but it might still not be what you want because that handles escaped ones. But it will find you, for example, a backslash, and it will find you... What else do you search for here? Split char.
In this case, a comma.
Yeah. It will find you split char as well. Both, and then you have to deal with whatever it is that you have to deal with. So it's a
Okay.
bit less potentially, but also, I don't know if it's more complicated or not.
Right.
In the interest of time, you know, I just have a hunch that this can be nicer, but also no real need. It's just a couple of lines. They don't look, you know, they don't at all look terrible or something. It's more like there might be nicer ways, but also we don't have to look for them forever. There's more important things to do, for sure. And this is very tight
This
now.
is pretty much the same as it was before, just in a nice little function.
So where does either come from? So usually I don't do this. Like just an unnamed either, I don't know.
Yeah.
I always, you know, even though you can cut the modules, I don't usually do it if it leaves me with this.
For sure. In this context, it makes more sense to put it there, but in the big function, when it was still a part of that, I thought, okay, let's make it as short as possible.
So now it's clear, and it doesn't change anything regarding the lines. Oh, and I broke everything, so I can't really do any.
And I have the changes written down.
Oh, yeah, cool. Yeah, so iterate over all of these, collect it into results so that you can get rid of the vector. That's very nice. Then you map the error and you are done. This is interesting. Expecting only error attribute name. Ah, yeah, right. This was the
one case, yeah, that we could maybe make it more distinct in the attributes crate. Yeah, haven't touched it yet.
Yeah, but that's okay. That's something we carry over from last time. So I think that's the comment for today. I reached the end of the file. So this is probably something I might just try myself for fun to see how that would work and if that makes anything any better, because I really often don't know. And the rest looks good to me already.
Oh, there was one more question I had, because it's about this unimplemented error. And that's, oh, excuse me. So Git has a bunch of reserved characters basically for these short keywords, and it throws an unimplemented error. So I just replicated this, but I was wondering if we need this or if we just ignore those basically.
Yeah, so if Git fails, it's probably not too wrong to assume we should fail too when we see that. If we ignore it, what's the outcome of it? What do people expect versus what do we actually do?
Yeah, I didn't even mean ignore. I meant like, do we need a specific error for these as well? Or can we just say, I don't know. Yeah, I don't know. I don't know if it makes sense or not. I just thought maybe it's a bit much replicating these reserved keywords from Git as well. But maybe that's also what's necessary.
Yeah, probably just necessary. Even though I wonder if this needs to be a B string. It's just a single byte always, huh?
True.
So maybe that should then be... Yeah, a U8 doesn't print nicely, so it should be a char. And you can just convert it into a char. That should work because you know these are ASCII, so they totally convert. And you can probably do something like B try into expect, something like that. And that way you still fail if something is unexpected without hardcore casting stuff that then makes no sense anymore. So yeah, but I think that's then it. So should probably mention that too. Yeah, that looks like the session is over.
I think that pretty much sums it up. There's a little bit more I have to do for like making sure all these escaped and unescaped things for the attributes. That's like just some more tests that I have to write there. but that's already in there. So I just have to make sure I handle it correctly. And yeah, for the test cases, I don't know, is there more that I can do than just scanning the actual PathSpec Git implementation for when they fail? Because I think that's what I did, and I think I pretty much fail at the same places that they do. Is that it for the baseline? Can we call it done?
Yeah, I think that's as good as it can get. If you didn't find any hidden tests that PathSpec has that we can learn from, then that's all we ever can do. But it's also quite a lot for, it's a faithful implementation then. And I think all the nitty and gritty details, they come when you actually try to implement them or try to use these PathSpecs, because the matching is an entirely different world then. And then you will see it's gonna get a whole lot more complicated. This is the, just some parsing. That's always relatively straightforward. So yeah, cool. But that's also a nice warm up, and nice getting used to a certain workflow, and yeah, wonderful learning experience. I'm happy you got to do the PathSpecs, and I'm looking forward to using them myself.
Yeah, me too.
So thanks a lot, everybody, and I hope to see you next time. Bye bye.
Bye bye.